Hello, Fiveable Cram friends. It is officially now Fiveable Cram season for AP Stats. Our exam is in 5 days. As a teacher, that makes me extremely nervous and also extremely happy to see that end in sight. I'm sure you are the same way as a student. But we are here to help you, and we are super excited to be able to help you. Tonight is night one of 5. So it is May 2nd, and we are going to keep doing this thing, same time, same place, until May 6th. All right, next slide. All right, so just some community agreements, so some things that we want to make sure that you all are aware of and are willing to kind of work with. Over the next 5 nights. Number one, be supportive of each other. Yeah, I see the chat's already blowing up. We already know where the chat's at. Be supportive, lift each other up, help each other out. Let's have good conversation, good dialogue aimed at helping us get to that score that we need on the AP exam for the college credit, which is why we're ultimately all here. Also, let's be patient with each other. We've got 5 nights together. We've got technology and all sorts of things varying and things going on. So make sure you are being patient with us and with each other. Also, be kind to us. We have a design team that put together a fantastic slide deck for us. We have a wonderful host team that has been practicing really diligently over the past few weeks, preparing for our streams, which start tonight. So be supportive of them, be kind to them, and we are going to rock and roll. All right, so some tips on how to make the most out of a cram finale. So number one, taking notes is going to be super helpful to you. So make sure that you are doing something in order to take notes. Make sure that that's going to help you to be more engaged and not be, on your cell phone or trying to surf something else on your computer or whatever it may be. Taking notes, being focused on that, writing down things. There's certain mnemonics, writing down questions that you have, throwing those in the Q&A or the chat so that we can help address those. Also, make the most out of the Cram Hub. There is a ton of stuff that is going to be available there. The slides, you can find the slides there. You can find the review packet. You can find replays if you had to hop out for a few minutes and have to hop back on. So you have that, hey, look at there, I'm up on screen again. Let's see, there we go. I think that's what we want there. So, oh no, now we're all there. All right, we're just having fun here with Crowdcast. Also, so the group chat, sorry, that threw off my train of thought. So the group chat and the Q&A tab, see, again, the chat's already kind of blowing up there, and the Q&A tab, and we can answer questions as we go. And also, we will take breaks, okay? So we will definitely have time for breaks. We didn't build in that as much with the preview nights if you were here, but we are going to build that in tonight and along with the other 4 nights. And the replay will be available right after the event via your Cram Hub, which you can see that link down below and Crowdcast, the find your slides and cheat sheets here link. All right, so this is our wonderful team. My name is Josh Argo. I am based in the Birmingham, Alabama area. I'm not going to give a football allegiance because I don't really care about football. I know it felt like being from Alabama, I should say either one of 2 things, and I'm not going to say either one of them. So anyways, so I've been teaching AP Stats for a while, and I have also been a reader for a while. So I can answer questions in the chat. Also, we've had discussions as a host team about all those things. So yeah, I'll kind of be in the background, kind of answering questions, helping things fly along. And tonight we have 2 wonderful hosts, and I'm going to let them introduce themselves before we get started.
Hi everyone, my name is Mariam. I'm going to be one of the AP Stats hosts for this session. And I'm also a high school student, so I'm really feeling AP season. So good luck to everyone.
Hey everyone, I'm Emily. I'm an 11th grader. I live in Gainesville, Florida, and I will be teaching night 1 and 2 and then being a cheerleader in night 3, 4, and 5.
All right. And also tonight, right now flying solo, we had some traffic issues, kind of delaying some of our team, but Jed is going to be helping us out with the chat and the Q&A. Jed, introduce yourself. I don't know if Jed's got a good audio connection. That's all good. Let's move on to the next slide. All right. So our agenda for tonight. So tonight we're going to be focused on descriptive statistics. If you're looking at the course exam description that AP puts out, that's going to be units 1 and units 2, describing univariate data and describing bivariate data. So the first half of the night, we are going to be on unit 1. We are going to be looking at the, we are going to, oh, we lost our slides. We are going to be looking at the, some, let me see if I can get mine back up. I should be able to throw that up real quick. All right, Miriam, can you get our slides? Take the one off the stage. Ooh. It's like, what's that game? There's a game show where you bounce around like that. That's what it feels like right now. Let's see.
It's saying I'm already sharing them, but it's not showing up.
Yeah.
Someone else could share them. That might work better.
Yes, I will share. If you can remove, because we ran into this the other night, if you can remove the one you were sharing before. There we go. That's what I needed there. Okay. So I was trying to take over doing that, and we were, it would not allow me to. Okay, so says a screen is actively being shared. So Miriam, I need you to remove the one you were sharing before. It's up in the wing right now because I was trying to get it off there. If you can remove that one, and then I can share. It won't let me remove it, I guess, since it wasn't my share.
I'm clicking the remove, but it's still there.
So down like on the bottom of your, where you have like your mute, your the bottom right where it has your share something, see where it has screen, if you can click the X there.
It's not letting me for some reason. It's saying that as the presenter to stop sharing.
I don't know. See if Miriam, you can refresh and see if it will allow you to do that. All right. We are going to get rolling here in just a second, everybody. Oh, there we go. Okay. I got y'all. All right, awesome. So part one of tonight, we are going to be with unit one, which is going to be mostly on the first part of statistics, describing data, and then we'll have a little break with some Q&A. And then the second part will be more on bivariate data, like scatter plots, things of that nature. And both sections tonight, we're going to kind of end each section with some free response questions that we are really excited about, that we are calling Pep's Statistical Escapades. So he's going on tons of adventures where he is gathering data, and it gives us a chance to practice for the types of free response questions that you will see on your exam. All right, be sure to follow Fiveable on social media, LinkedIn, YouTube, TikTok, Instagram, all those wonderful things. There's lots of great content there that you can get that will help you to make sure you're prepared over the next few weeks for all your AP exams. So every night I really want to start to make sure to start off with an idea of what is going to be on the exam and what is it going to look like. So the first section you will do a 40 question, 90-minute multiple choice, and that's going to be 50% of your score. And then section two is a free response section, which AP is very nice to us and gives us some very clear breakdowns of what the free response section looks like. And that night 5 finale, we're really going to go into detail, and hopefully you can know exactly what it is that exam is going to look like on the FRQ section. So our, again, you can see also the exam weight of unit 1 and 2. And if we're thinking about free response, number 1 on your free response on your exam on May 7th, next Tuesday, the day we all have circled on our calendar, is going to come from, it's going to be very similar to the 2 statistical escapades for tonight. If you know how to do those problems in their entirety, you're going to do pretty good on number 1 on the free response next week. I feel very confident in that, and that's the way we sort of designed this thing. All right, so I'm going to pass things off now. I'm going to hop up here in the wing and let them take over.
Okay, guys, so we're gonna jump right into unit 1, which is exploring one variable data. And it's a big chunk of the exam. It's like 15 to 23%. So make sure to pay attention. Okay, so first we're gonna be going into like an introduction to statistics. These might be like familiar to you guys already, but statistics includes a lot of collecting, analyzing, and interpreting data. And it's a great tool to use to be applied in real world situations. So it's used in practically every field, for surveys, analyzing data, testing hypotheses, and usually in science experiments and things like that, we would need statistics in order to analyze large forms of data. And it's becoming like increasingly relevant in today's world because we're seeing more and more big types of data with increased use of technology. So it's very relevant for us to know today. Okay, so we're going to be starting off with some univariate data. So there's 2 types of univariate data: categorical variables and quantitative variables. So categorical variables represent data in groups or categories, and they're measured in proportions. So some examples of univariate data in categorical variables are eye color and marital status. So that would be applied, like, for example, if we wanted to know how many people had blue eye color versus brown or black eye color, then the proportion of people who had each color would be the numbers that we're using in this situation, and each eye color would be a category. And the next type is quantitative variables. So quantitative variables are measured or counted variables, and they're measured in means. So for example, height or age, those are quantitative variables because you can have any number for height or age. There's not any type of categories in that. Okay, so as a check for understanding, are these categorical or quantitative variables? The number of marbles in a bag, class size, hair color, square feet, and population size. You guys can type the answers in the chat. Okay, so I see some answers popping in. So the number of marbles in a bag is quantitative because you're counting the number of marbles. Class size is also quantitative. Hair color is categorical because you can have different categories of hair color. And square feet and population size are both quantitative data. So here are some different types of graphs that we can use to visualize categorical data. So on the left, we have our bar graph, in which we have the different categories represented on the x-axis. It could also be a horizontal bar graph with the different categories represented on the y-axis. And the other axis has the number that is associated with the different categories. So here, the x-axis has the different categories of sports, and the y-axis has the number of students. And another way this could be used is if we're thinking about proportions, we could have the relative frequency on the x-axis, and the bar graph would look pretty much the same since the distribution would be the same, but the numbers on the axis would be different. So in this bar graph, we can see that the different numbers of students are on the other axis. And the second type we have is a pie chart. And this one has the different types of categories as different sections of the pie, and the percentages represent the proportion here instead of the counts. Okay, and then we're moving on to some more types of visualizing categorical data. So one on the left we have is a two-way table. So the two different categories that are being measured here is whether they like snowmobiles or they do not like snowmobiles. And the other axis measures whether they like skateboards or they don't like skateboards. And then on the margins, we have the margin totals. And these can help us find different proportions based on whether they like snowmobiles or they don't like snowmobiles relative to whether they like skateboards or they don't like skateboards. And on the right, we have a mosaic plot, which shows us the different types of variables and their proportions. So over here, we have treatment versus elderly. So the different types of treatment are measured, are shown by the different colors. And the elderly and not elderly are on the left and the right. And the area of the different sections of the mosaic plot are proportional to whether or not they're elderly on the x-axis and whether or not, and the percentage of treatment that they're receiving on the y-axis.
Alrighty, so now that we've done visualizing categorical data, let's do a little bit of quantitative data. So on the left here, we have histograms, which one of the most popular graphs for quantitative data. As Miriam talked about earlier, it kind of looks like a bar chart or bar graph, but there are gaps between each bar on a bar graph, and it's for categorical variables. So histograms have no bars or no gaps, and they are for quantitative variables. Sorry, I had a little script there. Okay, and we have stem and leaf plots on the left on the right side, and it's another great way to represent quantitative data. So we usually use the leading value or the tens value as the stem on the left side, and then the leaf on the right side is usually the units digit. It doesn't have to always be like this, so if I wanted to put 120 in the graph or on the plot, we could put 12 on the stem side and 0 on the leaf side. All that matters is that you have a really good scale. So a key or a scale, doesn't matter. You have to make sure the grader can understand what you're trying to say about these variables. So you could either have like 630 or you could have 63 as your key. Next. All right, box and whisker plots. This one's either a hit or a miss. It's kind of bad sometimes if you don't know what it is, but that's okay. All right, so on the left side here, we have the minimum value. This will usually be your like your smallest value if you do not have any outliers. If you have outliers, there will be some other X's on the sides on the left or the right side. We'll explain those later. At the end right here, we have your quartile 1, and this is usually the median of the minimum value and the median, and this is your 25th percentile. Your middle value will be your median, and it's when all the numbers are sorted in ascending order. remember that a median is basically the average of the two middle numbers. If there's an even amount. If there's an odd amount, you can just cancel them out until you get to the middle number when sorted in ascending order. And we have your quartile 3 here. It's the median of the maximum value, and the median, it is the 75th percentile. And then on your end over there is your maximum value. And if you guys can't tell, there's interquartile, which is 6Q3 minus Q1. We'll talk about how to determine outliers with Q3 and Q1 in a later slide. Okay, this is going to be a long one, but this is very, very important for Unit 1. We have SOCS. I don't know how else you want to say it. You could say like SOCS. I like SOCS. It helps me remember it better. But most AP teachers will teach this acronym. Mine didn't, so I had to learn it. But it's really easy, and it helps you memorize all the things you need to say when you're describing a distribution. So our first one is S, or shape. It can be broken down into 3 different categories. We have symmetry, skewness, and modality. Symmetry is basically when it's the same on both halves of the graph. This can be described as symmetric, approximately symmetric, or not symmetric, if it's definitely not the same on both sides. And then we have skewness, which is the measure of asymmetricness of a graph. We can say a graph is skewed right, which means it has a tail leading off to the right, or skewed left, which means it has a tail leading off to the left. Or we could say it's not skewed at all, which is usually when it's approximately normal. And then we have modality, which basically measures how frequently a value shows up. So we can have something like a bell curve, which is just one peak, which is what we call, I think it's it's unimodal. Sorry, I had a moment there. And then we have bimodal, which is 2 peaks, which is kind of like approximately symmetric, but there's 2 peaks on each side. And then moving on, we have O, which is outliers. Outliers are data significantly different from other values, and they often mess up statistical measures. Like, let's say we have like 3 really smart people who did like a 99, 100, 101 on a test, and then you have someone who got like a 33. That's going to mess up your mean. That's going to mess up your range, those ones that are easily thrown off by a value that's like low or outlierish. Okay, and we can determine outliers from multiple different rules that we'll teach later. C stands for center, which is determined by either the mean, median, or mode. We said earlier in preview night 1 that mean might not be one of the good measures, as it is easily influenced by outliers. So like a very small value or a very big value will mess that up. So the one we usually use is median, and it's good for any shape of graph. Mean is only good for approximately normal, and mode is like, it's like a whole, what's the word? Casino. And it's like, oh, do you want to go for it? I don't think you do, because the mode could be anything. It does not have to be the center. So it's never used as a measurement of center that's accurate. And then lastly, we have S, which is spread. There's 3 ways you can do this. You can do range and interquartile range, standard deviation, or variance. So range or interquartile range is calculated by subtracting the largest from the smallest. This is also very, very prone to like outliers. So a very high or very low value will make it a lot bigger or a lot smaller. And then we have interquartile range, which is Q3 minus Q1. This one is a little less prone to like shifting because of outliers, because it's the data sorted and you have it in order. So the values that are outlier will not be Q1 or Q3. They'll be on the left side of Q1 or the right side of Q3. And we have standard deviation, the average amount of variability in your data set, and it is very commonly used as a measure of variability. And lastly, variance is a measure of how far data points are from the mean. All right, so we talked about skew left, skew right, symmetric. You might not know what these look like. So if you look at this slide here, on the top left, we have symmetric, which is basically a bell curve. There's one peak in the middle and everything else is symmetric. Skewed right is when the tail is going off to the right. We call this a positive skew because it's going in the positive direction. Skewed left is a negative skew, and that's when the tail is going off to the right or the left direction, which is kind of negative. Uniform is when the frequency of everything is about the same, so it's like level on the top. And unimodal is when there's like one peak, like there's a very common occurring value, and that's in the middle for this one. And bimodal is when you have two modes and two peaks.
Okay, so I'm going to be going over when you should use the mean versus when you should use the median. Emily kind of went over this a little bit before, but just to reiterate. So the mean is when you add up all the values and you divide by the total number, so it's basically the average, and it is very easily affected by outliers. So if you have like a really big outlier or a really small outlier, that would affect the mean. And so because of that, it's the best measure of center if the distribution is not skewed or it has no outliers. So if it has outliers or it is skewed, don't use the mean because that will likely be messed up. Okay, so instead of the mean, what you should use in that case is the median. So the median is the middle number of the data. So if you line up all the data values from least to greatest, the one in the middle, or if there's an even number of data points, then it would be the average of the two middles. That number is the median, and it's great because it's resistant to outliers, which makes it a better measure of center when the data is skewed or it has. Okay, so now we're going to be talking about measures of spread. So some of them are range and IQR. So range is the maximum value minus the minimum value in the data set. And the other type of range is the interquartile range, which is Q3 minus Q1. So Q3 is the median of the right half of the data, or from the median to the maximum, the median of that. And Q1 is the middle of the left half of the data, which is from the smallest value to the median. So when you minus Q3 minus Q1, that would be the interquartile range. And that's just represented in the box plot by the box. And variance is another measure of spread, and it measures variability, and it's the average squared deviations from the mean. Standard deviation is basically the square root of the variance, and it measures how spread out values are from the mean. So like we talked about in the last slide, when it's skewed, you would use one, and when it's not skewed, you would use a different one. So in this case, when it's skewed, you would use the standard deviation as opposed to the range in IQR. And when it's not skewed or it doesn't have any outliers, you would use the range or IQR. And usually you would use the interquartile range because the range can be a little bit funky sometimes. But if there's no way for you to find the interquartile range, then or the standard deviation, then you would use the range. Okay, so how to determine outliers. There's two rules that we use to determine outliers. One of them has to do with the IQR. So for this rule, it's called the 1.5 IQR rule. And so we would multiply the IQR times 1.5, and then we would do Q3 plus the outlier. So anything that's greater than Q3 plus 1.5 times IQR would be an outlier. And likewise, anything that's less than Q1 minus 1.5 times IQR would be another outlier. So these are basically our two fences, and anything outside these fences would be considered an outlier. And sometimes when we're drawing box plots, they might ask you to, instead of including the outlier as part of our box plot, you would instead like draw a star or something to show that it's an outlier. And the other rule that we use is the 2 times standard deviation rule. So values more than 2 times standard deviations above or below the mean would be considered outliers. And usually in multiple choice questions, if they're asking you to find an outlier, they would tell you which rule you need to use. But otherwise, just using the rules in the previous page about whether or not it's skewed, we would know which rule to use. And if it's an FRQ in which we're asked to describe the distribution, we would need to remember to include a summary sentence at the end stating whether or not there are outliers and how we know based on these calculated values. So even if there are no outliers, we would still need to state that we know that because of the 1.5 IQR or the 2 times standard deviation. Okay, so this is a quick check for understanding. So there's a dot plot here that shows the number of songs on each album in Pep's collection, and each dot represents a different album. So this dot plot just represents the distribution. And here's the five-number summary for these data. So according to the 1.5 times IQR rule for outliers, how many low outliers are there in the data set? So why don't you guys try to answer that and type your answer in. Or I'm sorry, in the poll. The question says, what is it? Yeah. Okay. It looks like some people put some votes in. So the answer is that there's actually 0 outliers, since 1.5 times IQR is 6, and then 6 less than 10 is 4. So since there's nothing less than 1.5 times IQR, there are no low outliers. So if it's on the fence, then it's not an outlier.
Alrighty, okay, let's talk about comparative analysis. So we use comparative analysis to compare two different graphs. Why'd you pass on those lines? Sorry, I just started blabbling. Okay, and we want to use terms like, next click, yeah, greater than, less than, or equal to, rather than language arts terms like however or while. Alrighty, so let's try this question out. So what do these graphs tell you about spring and summer versus fall and winter? You guys can answer this just straight in the chat if you want. Okay, you guys had pretty good answers in the chat. I can pin one that I think is good. Let's see. We'll just pin this one. It's pretty good. Okay. So both of them are skewed right. One of them seems to have a higher unimodal, but that's okay. It has a higher frequency for one of the values. You guys can talk about centers as well. And then a little bit of, we can make some adjustments. All right, we're gonna move on a little bit because we have other things to get to, but good answers. So make sure you include all three parts when you're describing. Don't just include just the shape or just the center or just the spread. Make sure you explain how you got each of them as well. Maybe you can say like, oh, it's skewed right because the tail's off to the right. And for range, Ethan just asked how you can find the range. You're gonna look at the highest value and the lowest value. You're gonna subtract them. We can go next slide. Yeah, okay. All right, normal distributions. I feel like if you chose one thing you had to remember from AP Statistics, it'd probably be normal distributions. Like in 5 years, I'd remember what a normal distribution is. Okay, so a normal distribution basically looks like the image on the right. The characteristics it must have symmetry. It must be a bell-shaped curve. The tail's asymptote towards the x-axis, and it's unimodal. Remember that shape, and you can categorize it as bell curve or normal distribution. Okay, if you guys came to AP Review Night 1, you guys would know that I kind of talked about this a little bit, but we never had an actual slide about this, so I'm going to teach it again. So in an approximately normal graph, you have an empirical rule, which is very, very useful to kind of check your z-score calculations and stuff like that. So if the data is normal, remember 68% of all values fall within one standard deviation. 95% fall in between two standard deviations. So front to from the left side to the right side as well. So look at the arrows pointing on the picture on the right, and 99.7 fall within three standard deviations of both the left and the right. You guys can either force this in your brain. Maybe someone has like a little memory acronym you guys can use, but I just hard memorize this one because this is very next. Okay, cool. All right. So our standard normal distribution is a normal distribution with a mean at 0 and a standard deviation as 1. And we can use this to calculate z-scores. So before we give the formula of how to calculate z-score, we're going to just say z-score is a measure of how many standard deviations you are from the mean. So if you get like 2.25, you're going to be 2.25 positive, so to the right side away from the mean. Or the median, it's the mean. Sorry, that was a little, okay. And then our formula right here is the given value they give you minus the mean over the standard deviation. And you can see which symbols are which on the side.
All right, y'all. So let's take a little break. Let's stretch our legs. I'm loving my Dunkin' coffee extra large that I had. If anybody lives close to a Tim Hortons, I have a really weird obsession with Tim Hortons, but Dunkin' Donuts is the best we can do in Alabama. So y'all take a nice little break, and we will come back and do some practice problems for Unit 1. Woohoo! One thing I did want to mention during the break real quick, it has to do with the outliers. So let's see. I'm actually going to go back to the slide, and then I'll just kind of keep a track on our timer. That way we can make sure we see that. Take a stab. Hey, I was right, 21. So based off of the 5-number summary that we're given, our IQR is Q3 minus Q1. So that's going to be 13 minus 9, which is 4. 1.5 times 4 is going to be 6. So then to find our outliers, we're going to take Q1, 9, and subtract 6. That gives us 3. So the cutoff for any outliers is anything less than 3. And since our minimum is 4, we don't have anything less than 3. That's why there were 0 outliers. So hopefully that sums up that for you, that little topic there. And that is, I think that's a really big idea. I would kind of circle that in your brain for number one on the FRQ, because I think it's likely they would give you that somewhere on the FRQ, that IQR formula. People struggle to memorize that, so definitely study that. Circle that on your slides, your printout, whatever. Right, we'll do about, I'm gonna move the counter down to about 2 minutes. And we will finish our break. Feel free to ask other questions in the chat during the break if you would like. All right, y'all, we are back. So we did have a few questions that I want us to be able to go over from the chat. Okay, so I'm going to give our student hosts a minute to answer some of those questions. Let's see, I like this one here, and I'm just going to go ahead and put it up on screen about going over how to find the center. So the mean, median, and mode. How would you go about finding those? If Emily or Miriam, y'all want to jump in on that?
I can do it. Yeah. Okay. So for centers, we have mean, median, mode. So mode, I remember watching that frog video when you guys were little. Do you guys remember the frog video? I hope not. Or maybe it was probably a long time ago. So the mode is the most repeated values. So when you look at a set of data, you count like how many 4 show up or how many 5 show up, and which one shows up the most is the mode. So if it's like 4, 5, 5, 5, 6, it's gonna be 5. And then median is when you line the values up in ascending order. So like 1, 2, 3, 4, 5, 6. And then you cross the biggest value and the smallest value out, and you cross them until you get to the middle. If there's one value left, that is the median. If it's not, then it's going to be like the average between the one, not like, how do I explain this? If there's like an even amount, you're going to do the 2 in the middle, and you're going to find the average of the 2. And then mean is when you add all the values up. So it's like 1, 2, 3, 4, 5, 6. And you divide by the number of numbers there are, if that makes sense. So like 1, 2, 3, 4, 5, 6 divided by 6, because there's 6 numbers. Is that good?
And like if there's like a really large data set, you guys might want to use the calculator to figure it out. So to do that, you would like put all your values into L1. and then you would run one var stats on there, and then it would just like find everything for you. So that might make it a lot easier.
Yep.
Since it's probably really tedious to find the mean of the large data set.
Hey, also in terms of calculator, so we had a lot of questions from the preview, and I'm sure it was from some of you on using the calculator. So we are going to do a calculator session. This is the first time student hosts have heard about this too. We're going to do a quick calculator session one of the nights this week. More than likely, night number 2 or 3. So either tomorrow night or Wednesday night. So if you need help using primarily the TI-84, I'm trying to track down a computer that has my license on it because I got a new computer and it didn't transfer the license. But we are going to go over using the calculator. So just know that if you're here every night, we will have that time to go over that.
Okay, so now we're going to be diving into like a little mini FRQ of one of PEP's statistical escapades. So for this one, PEP has become rather interested in the weather field, and in the past 12 days, PEP has collected data on the amount of rainfall that happens in Chilitown, USA, and the results that are summarized to the left in the dot plot. Next. Oh. Okay, so determine the 5-number summary for the data set above. So if you guys don't remember, the 5-number summary is the minimum, Q1, the median, Q3, and the maximum. Okay, if you guys found that out by now, Jed, do you think you could press? Okay, yeah. So the minimum is 0, Q1 is 0, the median is 1, Q3 is 2, and the maximum is 6. So the minimum and maximum are pretty easy to find just by looking at the graph. And then for the median, you could count out all the different dots to find out which one's in the middle. And then in this case, that's 1. And Q1 is 0 because the middle of the everything to the left of the median is at 0. And then Q3 is 2 because the middle of everything to the right of the median is at 2. And the max is 6. And if you guys put all this into your calculator and ran the one var stats, you could find this out as well using that. Okay. The next question is describe the distribution of the inches of rain per day in Chilitown. So in order to do this, you guys have to use the SOCS acronym that we learned before, which is spread, outliers, center, and shape, outliers, center, and spread. Oh, and Emily just pointed out that Q1 is actually 0.5 because since there's 2 in the middle of the left half, it's between 0 and 1. So when we take the average of 0 and 1, that would be 0.5.
Yeah, if you put in your calculator one variable stat and then one variable stats after you put it into L1, you get that. I changed it on a slideshow from preview night, but I forgot to change it on this one. So Some of your answers will be wrong according to the slideshow. I'll post the right answers in while she's reviewing it.
Okay. So for the answer for B is that the distribution of inches, if Jed, if you could press the button. Okay. The distribution of inches of rain in Chilitown has a median of 1 inch. So doing that, we covered the center, which is the median. And then the distribution is skewed right since it has a long tail to the right. And it has a potential outlier at 6. Here it doesn't really say how they found it, but you should talk about, like, if you use the 1.5 times IQR rule, you could talk about that. But just by looking at it, you can also tell that it's an outlier. And the number of inches of rain vary from 0 to 6 inches. Ideally, you would also say the spread. So you could say that the range is 6. Okay, so here it asks you to determine if there are any outliers using the 1.5 times IQR rule. Okay. So for this one, to determine if there are any outliers, you'd use the 1.5 times IQR rule. So if we already found out from the 5-number summary what the Q1 and Q3 are. So I think Emily said that the Q1 should be 0.5 and Q3 is 2. So 0.5 minus 1.5 times 2 is not -3, but that's what you should have done. And then sorry, not times 2, times 1.5, since 2 minus 0.5 is the interquartile range, since Q3 is 2 and Q1 is 0.5. So it should be 1.5 is the IQR. And then 0.5 minus 1.5 times the IQR, which is 1.5, is the lower bound. So that would be negative 2.75. So anything less than that would be an outlier. And then 2 plus 1.5 times the IQR, which is also 1.5, is 4.25. So anything greater than 4.25 would be an outlier. And here, since 6 is greater than 4.25, it should be an outlier. Okay, there's the last part of the question, which is pretty long, so you guys can read that. But basically, the maybe mayor of Chilitown, Little Wall, says that the mean is 1.5 inches per day, which means that in a month they're going to have 45 inches of rain. But he made an error in his claim, so what would be a better representation of the data instead? Okay. Do we go to the next?
All right, Miriam is being overtaken by the pep. Oh, she's back. All right, do you want to take over again?
No, it's okay.
All right, I can do it. All right, I did this question preview night one. All right, so we're currently using the mean, but that is, as we can tell from before, we had an outlier on the top right side. So I told you guys that using mean is not good when there's especially outliers and stuff because that will strongly influence. So with our very routine answer, since our data is skewed, using the mean could represent the center represent the center is misleading because it would be strongly affected by outliers and skew. The better representation for center would be median, which is 1. So remember that mean is only good when it's approximately symmetrical and there is no like strong outliers on either side. So the safer option would always be median. Yes, as Tara says, it is more resistant to outliers.
All right, it is Cram quiz time, everybody. So the link to the Cram quiz is in the chat. It is not letting me put it up as a link on the at the bottom where it says PEP Statistical Escapades. For some reason, that is not wanting to work. So it is in the chat. So go join us over there.
Hey guys, are you ready for
Woo-hoo!
some
Music?
Woo!
The most important part of Cram quizzes is the music, and I forgot it. All
So
right.
we'll take a couple more participants.
And don't worry, the music will come back. It absolutely will come back. Just got a little hint of it. All right. Remember, the link is in the chat. Oh, we got it in a call to action now. Nice. Whoever got that figured out. Awesome. Awesome job. All right.
Okay, so for the first question, we have, sorry, can you put the screen up a little bit more? So which type of graph is commonly used to display the distribution of a categorical variable? So you can choose either a box plot, scatter plot, histogram, or a bar graph. Wait till you get a couple more. Okay. So bar graph. Okay, so we did really good on that one. So yes, so bar graphs are commonly used to display the categorical variable, because remember, usually like on the bottom, you'll see some type of like category, like, oh, if it's like different colors. You'll see like, oh, like maybe like pink or something like different like that. But box plot, histogram, and scatter plots are all usually used to use quantitative data. So to represent variables that have numbers in them. So I guess something like the amount of time that it takes to finish a test, because that's in minutes and that's a quantitative variable. Music's back on. So, which statistical graph would be best suited to display the relationship between two qualitative variables where one variable has much more levels than the other? Oh, I didn't even realize that it actually has the answer. So we should get 100% success rate on this one, guys. Okay, so yes. Oh, we still got, okay. So yes, mosaic plot because it adjusts tile areas according to relative frequencies and accommodates differing numbers of levels well. So remember, the mosaic plot is the one that looks kind of odd, like there'll be different size like squares. And so like, so it adjusts it based on the frequency of the variable as well as how many there are. So like the sample size, for example. So if one has like, 175 and the other one has like 75, the one where it has 175 would have a bigger width on the bottom. So remember that. So levels does matter. And also, so that's where it kind of talks about levels or like the tile areas, because if you have like two different things, like say you have girls and boys, like girls can be on the bottom, boys will be on top. So that's what it means by levels. Yes, so we know C is not right because other options are less effective because it says regardless of the level count disparities, and we know that levels matter when we're talking about mosaic because both the levels matter and the frequency matters. So, when comparing the distributions of two different classes test scores, which graphical representation would allow you to see both the center and spread for each class's score on the same graph? So you can choose a histogram with non-overlapping intervals, a pie chart with percentages, a single box plot, or a Come on, guys, let's get that participation rate up. 33 out of 42. Get a little bit more. So back-to-back stem plot. Okay, this one we had a little bit of, okay. So back-to-back stem plot. So remember the stem plot is the one where it's like, it has the line in the middle and it has numbers on both sides. So the pie chart with percentages, you know that's not it, because a pie chart, you cannot see the center and spread. That's the one with the circle, and it's really only used for categorical variables. And then histogram with non-overlapping intervals. So we had a couple people choose that. And I see like how y'all got that confused, but remember you're looking for two different class test scores. With a histogram with non-overlapping intervals, that means you'd only be looking at one class and then you try to like put them all into one. You wouldn't be able to properly be able to compare the two different classes. And then with the single box plot, there's two different classes, so that automatically doesn't work. So that's why it would be the back-to-back stem plot, because on one side you can have one class's test scores, on the other side you can have the other class's test scores. Yes. Does that make sense? So when interpreting summary statistics after removing an outlier from a data set with no other significant skewness or unusual features, what likely impact would you expect on the calculation of variance? So it will likely decrease, it'll likely increase, it will remain unchanged, or there's no predictable effect on variance. Okay, so it will likely decrease. So we did better on that one. So remember, variance is a way to calculate, it's one of the ways to calculate the spread of the distribution. So when you have an outlier, outliers have a high like effect. They have they're very influential on the distribution, especially if there's no other significant skewness or unusual features. So that means that that outlier will cause a very big change. So what likely impact would you expect on the calculation of variance? So if you remove that outlier, that means there will be no significant skewness or unusual features because the outlier is removed. So therefore taking away that influential point and making it so the calculation of variance will decrease, because remember, it varies less because there's already no significant skewness or unusual features. So if an outlier exists in a data set, which measure of spread is least likely to be affected? Variance, interquartile range, or the standard deviation? So interquartile range. So the difference between all these ones, so the interquartile range, remember that's when it's cut into quarters and you're looking for Q3 minus Q1. So of course that one's going to have, it's going to be least likely to be effective if an outlier exists in the data set, because remember, so the measure of spread. So variance is the standard deviation squared. And then the range, that's where you're subtracting the highest minus the lowest. So of course, these ones are going to be really affected because we're looking for an outlier. And so standard deviation, that's also the distance away from the mean. So the interquartile range will be the least likely to be affected because it's kind of further apart from like the last the last numbers in a data set, basically. If that makes sense. I hope that makes sense how I explain that. Yeah. Which degree statistic is not displayed in the box plot? Third quartile, mean, minimum, or maximum? Come on, guys, you know this. Let's answer. 30 out of 43. Oh, we got that 100% right. Okay, guys, don't play. Don't play. Good job. Good job. Pat yourselves on the back. In a standard normal distribution, what is the z-score for an observation that is half the mean? I won't really read these ones out. But... don't let this one confuse you. Okay, z is equal to 0. Okay, we did that really well. So remember, the z-score is how many standard deviations it is from the mean. And so if it's already at the mean, that means it's 0 because there's no standard deviations away from it. It's right at that mean. Okay, in a perfectly symmetrical bell curve, what value does the mean equal? So where's that last one? Interquartile range, median, or mode? 92. Okay. Good job, though, guys. So the mean is equal to the median in a perfectly symmetrical bell curve, because remember, if it's perfectly symmetrical, they're both going to be at that same spot in the middle because there's no, like different skewness that makes, like the mean greater than a median or equal to the median. So that's just one little thing that you would want to remember. And then the interquartile range and mode, those are, If you want to assess whether there's an association between gender and preference for online classes over traditional classes, what type of graph would best display this relationship while also accounting for the proportionality within each gender? So relative frequency by class type and gender, mosaic plot, a simple bar chart, or 2 pie charts, one for each gender. So we talked about this graph earlier. Okay, so mosaic plot. So remember, this one is the one that accounts for both the frequency and the size. So when we're talking about, what type of graph will best display this relationship, we're also accounting for the proportionality, and then we're also looking for association. So remember, with mosaic plot, you can see both the frequency and the size. So the size also matters. So this one, it can be a little bit tricky. So just make sure mosaic plot, that's sometimes on there. It's not, but just make sure that you know what it is. So relative frequency table by class type and gender, I could definitely see how you got that one. But remember, we're looking for like the best type of graph. And so stacked bar chart and then 2 pie charts. So pie charts, you should already know that if we're looking for association and account for the proportionality, I can definitely see how you could get this. But you're only looking for like one type of graph. It looks like it's all of that in one. Okay, so which graphical method would best display the key features, center spread, and outliers of data from an individual quantitative variable? So the box plot, as it explicitly shows medians, quartiles, and potential outliers within a data set. A line graph, which connects points representing changes over time for continuous data sets well. A bar graph, as they effectively demonstrate frequencies or percentages among categories, or a pie chart, since they can show percentage breakdowns of categorical variables. Okay. I don't know where the music went, but okay. So which graphical method? So the box plot, as explicitly shows medians, quartiles, and potential outliers within a data set. So a lot of you guys chose C, a bar graph, as they effectively demonstrate frequencies or percentages among categories. So remember, a bar graph is good for categorical variables. Remember that bar graph is really good for categorical variables, and we're looking for an individual quantitative variable. And so you already know, like, line graph, pie chart, that has something to do with it. So pie chart, this categorical. Line graph, that really has nothing to do with this, because remember, we're looking for a center, spread, and outliers. And whenever we're talking about like the center and spread, that usually doesn't talk about line graphs. So the box plot, because it shows your medians, the center, quartiles, your spread, and then potential outliers in the data set. get all that with a box plot. We did really good though, guys. Good job.
All right, everybody. So we are halfway through the evening. So we are going to take another break. This one for about 10 minutes. Give everybody time to stretch their legs, get a snack. Be sure to hydrate. I'm going to finish the rest of my Dunkin' coffee and then also get probably some water as well. Caffeinate, then hydrate, right? So yeah, we'll be back in 9.5 minutes.
All right, guys, we're back from our break. We are going to start talking about Unit 2, which I will hand to Miriam.
Okay. Unit 1 was about exploring one variable data. So Unit 2 is about exploring two variable data, and it's worth a lot less of the exam. So it's worth like 5 to 7% of the exam, but we're still going to go over it. Next slide. Okay. So relationship indicators help us to describe relationships. So a positive relationship means as one variable increases, so does the other variable. A negative relationship means as one variable increases, the other variable decreases. And no relationship means there's no pattern in the data. So these are usually used to describe like when you have a scatter plot of data, whether there's a positive relationship, a negative relationship, or no relationship. And then if you were asked to describe it, you would use the sentence to the right. So you would say, as X increases, so does Y, and like in context. So when you're describing relationships include context. So instead of saying X and Y, you would say what the X variable was and what the Y variable was. Next slide. Okay. Okay, so this is an example of describing a relationship. So in this graph, we have the number of exams this week on the x-axis and the number of hours of sleep on the y-axis. So as we can see, like as you go to the right, the y variable decreases. So as x increases, y decreases. But since we need to include context, we would talk about the x as the number of exams this week and the y as the number of hours of sleep. So the sentence would look like, as the number of exams a student has this week increases, the number of hours of sleep a student gets per night decreases. And this example demonstrates a negative relationship for this bivariate quantitative data, which basically means there's two variables and it's quantitative data. So our sentence, which would include not only like whether it's negative or positive, but also whether it's linear or not, and the strength of relationship, we would say there is a moderate negative linear relationship between the number of exams this week and the hours of sleep a student gets. Okay, so here are some of the different types of graphs that we would use to visualize two variable categorical data. So this is not quantitative data, it's categorical, but there are two variables. So side-by-side bar graphs compare the proportions for categories of two variables. So in this example, we have different types of land animals. Those are one of our categories. And the other type, and then on the y-axis is the height of the animals. And then since there's two categories, there's male and female. And the male is represented in the blue and the female is represented in the red. And one good thing about this type of bar graph is that we can easily compare the heights of different types of one category based on the other category. So here it would be like based on one land animal, we would compare male and female for each one based on their height. Okay, the second one is a segmented bar graph in which we compare proportions of each category in one variable across the other variable. So over here in this example, it says burgers sold over the weekend, and the graph looks like a burger. So we have Friday, Saturday, and Sunday, and then vegetarian, chicken, and beef. So these are two types of categories, and we're comparing for each day the different types of burgers across that. And our last one, I know some people were asking about that, is the mosaic plot. So this one, the area really matters in terms of showing which category is represented how much. And so it compares proportions of different categories, and it's like a visual representation of a two-way table. So in two-way tables, you know how we have different categories and then how they correspond to other categories. And then here we would represent that with, if in one category it has a larger value or larger proportion, that would mean a greater width. And then if in the other variable it also has a larger proportion, that would be a larger width.
Where you're joining us from, if you're not like at home for some reason. Talk about what you might want to major in college, what colleges you're looking into, what kind of drew you to AHS, and then one fact that you might want other hammies to know. So maybe you're like really into cats and you want to pull out your phone and show us a picture. Feel free to do so. They'll last around 15 minutes, and we're trying to make them small so everyone has time to chat and like get around. And yeah, we're gonna split you guys up in a second, so just accept the invite.
All right, y'all. I don't know what that is. That is really weird. Let's see if we can get that figured out. All right. Let's see. All right. I think we're back. All right. Take her away, Scatterplot.
Okay, sorry about that, guys. I do not know what was going on, but okay. Fortunately, we're back.
The heart of Queens, New York, so New York City. Why I joined AHS? Honestly, I came across it like 2 days before the deadline. But I was really inspired by the mission of like the program. It was like I was just really looking for some like support and guidance in college essays as a stressed out junior, and also the opportunity to visit Seattle, which like I really wanted to because so the fun fact about me is that I'm like obsessed with Grey's Anatomy, and like a bunch of shows that I have watched were filmed in Seattle, so I'm like, oh my god, like I get to go there, like that's so crazy. Okay, so what I want to major in right now, so I'm a STEM girly. I'm looking into pre-med, anything like that, like STEM pre-med, something like that. Colleges, honestly, I have not done my college search, so.
I just want to say that all of us are muted, so this is just like delusion at its finest.
Wow, that's crazy.
So I don't know if you guys watched Grey's Anatomy, but like my favorite character there is Meredith Grey. She's like the head, like basically the main character. And I wanted so I called him Quacker Grey. So like Quacker.
I believe we are good now. I think we have found the problem. All right. Yay. Thanks for hanging in there with us, everybody. That was really unusual and really strange. Wow. Fun stuff. All right. Scatter plots. Take her away.
Okay. Okay. So back to scatter plots. So this is a way to represent two variable data because you would have an x variable and a y variable, and then you would just plot all the points and then try to figure out the relationship between the x and y variable. So in this relationship, you have a dependent or response variable and an independent or explanatory variable. So let's go over the independent variable first. So the independent variable is like basically the cause. So it's what's used to explain and predict the response variable. And it's also called an explanatory variable. That's important to remember for like MCQs and stuff. So in this example, it's usually the x value. So in this example, it's the number of exams this week because the number of exams this week is affecting or causing the number of hours of sleep. And that makes the number of hours of sleep the dependent or response variable because it can be explained and predicted by the explanatory variable. And that is usually appearing on the y-axis. Okay, next slide. Okay, so when we're describing scatter plots or describing the patterns in scatter plots, there are three things that we need to describe: direction, form, and strength. So direction means whether it's positive or negative. And as we were talking about before, when you go from left to right, the direction of the pattern is determined by whether or not the y is increasing. So when you're going from left to right on the x-axis, if the y values are also increasing, that is a positive relationship. And if when you're going from left to right, the y values are decreasing, then that's a negative relationship. The next thing we need to describe is form, which is the general shape of the pattern. So while we can have many different types of shapes like linear, curved, exponential, for this scenario, we just need to describe whether it's linear or not. So when you're writing your like sentence, you would say, is it a linear relationship or is it non-linear? And third is the strength, which is how closely the values fit the pattern. So that would be, is it weak, moderate, or strong? Okay. I think we're going to be doing more about this on the next slide. Okay, so and the last thing is unusual features. So are there any outliers, clusters, or gaps? So in this scatter plot to the right, why don't you guys try to describe that using strength, form, trend, and unusual features. And you guys can like type your answers into the chat as well. Okay, I think a lot of people are getting it in the chat, which is really good. So we would say that this has a strong, positive, linear relationship with two potential outliers at maybe like 0.5-ish and at 6. So that's basically what we would use to describe it. And I think Jed was also saying to make sure to include a context sentence at the beginning. So make sure to do that as well. And I think some people were talking about like different mnemonics for this. What I learned is the mnemonic stuff. So like S is for strength, T is for trend, U is for unusual features, and F is for form. So I don't know if that helps, but if it does, that's okay. Okay, so now we're going to talk about the correlation. Oh, sorry.
All right, so we have our correlation coefficient, which is R. We have the formula here for R, which you will probably not need to know. You guys can put this into your calculator and it will find R for you, because I do not think you want to spend that amount of time trying to calculate R. What does R tell us? It measures the linear relationship between two variables, minus or plus for direction. So if we want a positive relationship, it's going to be sloping up like this. A negative one, it'll be sloping like this. And then 0 is no correlation at all. So like randomly scattered points, like it does not have any correlation. And then 1 is like straight line like this. And it's going to be a very, very strong positive linear relationship. So make sure you remember that correlation does not equal causation. R is not resistant to outliers. So if there's something up here or up there that does not correspond into the line, that is going to bring your R down. And then curve relationships can sometimes have a high R magnitude. So make sure you check that. All right, so we know that R values range from -1 to 1. So -1 is that very strong negative. -0.7 is like a little more scattered, but not too much. You can still see the pattern. -0.4 is also pretty scattered, but you can tell it's a negative relationship. 0 is just points everywhere, just a free-for-all. 0.3 is a little bit of a like a weakish kind of strong, not weakish, strong, weak positive relationship. And then as we go up, it gets stronger and stronger. So remember, 0 to 0.5 is weak, 0.5 to 0.8 is moderate, and 0.8 to 1 is strong. Make sure you look at that R before you describe it so you remember which one you're supposed to be using. All right, so LSRL, which is least squares regression line, models the linear relationship between independent and dependent variables. So we have a y hat, which is y hat is the predicted value. Remember the little hat, please don't forget the hat. The predicted value of the dependent variable, x is the value of the independent variable, a is the y-intercept when y hat is when x is 0, and b is the slope. So the change in y hat for a given change in x. Alrighty, so LSRL, which is your least squares regression line, to predict y hat for x. When you have points inside the data point or the data set and you have a point like here in the middle, it'll be interpolation because you have points surrounding it, so it cannot extrapolate, which is what we're going to talk about next. Extrapolation is when you have like a bunch of points clustered and you're looking for, like, let's say like you have like one like parentheses 1 2 and like 2 3, and they have like 15 and you're trying to find the value of y. That's going to be extrapolation because you don't have values near that, so you don't know like what if it slopes up like really high there or something. So you have to be very careful about extrapolation. So the farther you go outside the data set, the less reliable your predictions become. All right, here we go with our formulaic how to get a 5 statement. So remember, you guys have to remember this one. Slope, there's a predicted increase or decrease of the slope unit of y variable for every 1 unit of x. So let's say x is like age, and then y is like the number of burps. I think that's what we were talking about earlier. So there's a predicted increase of, like, let's say like 1 minute of burps for every 1 increase in like age, like 1 year increase in age. And then our y-intercept, the predicted value of blah, is y-intercept when context for x is 0 unit. All right, so like the predicted value of number of burps per day is 2 when let's say your age is 0, and then our unit is sorry, I'm trying to channel the unit, 0 age, so 0 years old.
Okay, so another thing, in addition to the scatter plot for the actual x and y that we use to determine whether it's linear, is our residual plot. So residuals measure the fit of a linear regression model to the data. So basically, a residual is the actual minus the predicted. So the actual y that comes from our data minus the predicted y based on our line. So a smaller residual means our actual and predicted are closer together. So that means it's a better prediction. And LSRL is the least squares regression line. So it basically minimizes the sum of the squares of the residuals. And not that you need to remember this, but they're squared because otherwise there would be positives and negatives and they would cancel out. But what you do need to remember is that the residual is the actual minus predicted. Okay. Next slide. So residuals are plotted on a vertical axis. So if a residual plot for LSRL appears random, that means like there's no pattern at all, not a curved pattern, not linear pattern, just there's no pattern at all. It's basically just a messy plot. That means that the explanatory and response variables have a linear relationship. So other patterns that could happen that you want to avoid, or that you would look for a residual plot that avoids, are curved patterns. That means there's a nonlinear relationship, or increasing or decreasing spread, like we see in the bottom graph, that shows that the prediction of y changes in accuracy as x increases. So that's also bad. So we don't want that. So when we're looking at our residual plots, we want one that's truly random, like the one that we see at the top. So if there's any sort of pattern, like the curved or the increasing spread one, that means that it's probably not representing a linear relationship in the actual data. Okay, so this is just a little check for understanding. So based on the residual plot to the right, is the linear regression model appropriate for the data? There's a poll inside the polls section that you should fill out. So based on the residual plot, is it a linear regression model appropriate or not? I know some people are doing it in the chat, but if you guys could do the poll, that would be great. But yeah. Okay, looks like not a lot of people made it to the polls, but that's okay. I know a lot of people were saying no, so that is the correct answer. So it's not a linear model is not appropriate for the data because it's not random. It doesn't look messy. There is a clear like curved pattern to the data, which means that we cannot use a linear relationship to talk about the data. Okay. Next slide. Okay, so this is the scary computer mini tab outputs that we need to know for the exam. Okay, so in this computer mini tab output, there's like a lot of words and stuff going on that we need to understand. So what is S? So in the bottom left, it says S equals something. So S is the standard deviation of the residuals. And the formula of that is at the top, but basically it's the standard deviation of the residuals. And there's some other stuff on this mini tab output as well. On the top, it says the constant and coefficient where they intersect. That is the y-intercept value. And then below the y-intercept is the slope. So where it says miles driven, or it won't always say miles driven, that's just the x value in this case. And under coefficient, that's the slope. So basically in the first column at the top is the y-intercept, and below that is the slope. On the bottom left where it says S equals something, S is the standard deviation of the residuals. And then R squared is kind of intuitive because it says R SQ, that is R squared. Okay, I think we're going to take a 5-minute break now.
Real quick, while we're in a break, I know there's a question in the chat about using the TI Inspire. Whenever we do our quick little calculator cram, I will go over the 84 and the Inspire. I was trying to pull it up to do that real quick here in the break, and again, TI is not letting my account, it's not registering my license number or whatever. So anyways, I will have that for you all the night that we do the calculator cram. And I think we'll aim for that tomorrow. I think we have a few less slides tomorrow, so we will tack that on to the end. I can share my screen with both calculators and go through some of the basics. So if you need some calculator help tomorrow, we will run over those two maybe during the breaks or something like that.
Alrighty, we are back. Let me move everybody back into the left stage. Alrighty. Alrighty, we're back to our least squares regression line. And then we're going to talk a little bit about outliers and then high leverage points. So they're a little different. Okay, so outliers are when the y value is pretty far away. It will reduce the correlation and will likely change the y-intercept. You can identify it through a high residual, which is the expected, or the actual and the expected. So it's usually actual minus expected, if I'm correct. And then we have high leverage points where the x value is far away. So that can change the slope or the y-intercept. So for outliers, remember it's y, and for high leverage points, it means x. Okay, r squared. We talked about this a little bit in the chat, I believe, but we can reiterate. So r squared is basically the square of r, or the correlation coefficient. So like, let's say the correlation coefficient is like 0.9. Our r squared is going to be 0.81. So we're back with our how to get a 5 phrases. So let's say I use the example 0.9, so 0.81. 0.81% of the variation in what is it again? Amount of burps per day is explained by its linear relationship with age. And then by using we can use two. So by using our linear regression model, our predictions improve by 81% as opposed to using the average of our x coordinates and average of y coordinates. So those are the phrases you got to use when you're explaining an R-squared question. Okay, this is an interesting one. So, sorry. There's a lot of things we want to cover, but we only have 3 hours. So if you guys ever need help, there's an AP Stats library for unit guides and previous crams, and there's a lot of practice questions on there as well. There's like a cheat sheet, I believe, on there. And so if you don't understand anything, you can either ask us in the Q&A or you guys can use Pebble, because there are a lot of things you can use on there to help you study. All right, let's answer these really quickly in the chat. So when each question comes up, just give a quick, like, little explanation or a quick answer. Alrighty, so we have a lot of right answers. I will put Tara's up since she answered it first. And there's many right answers after that. Good job. Alrighty. Okay, we can move on to the next one. Next one. Smile. Uh-oh. Okay. I will. Okay, what does it mean if two variables have a correlation coefficient close to 0, 1, or -1? So you can answer that as like A, B, C, or like 1, 2, 3. Alrighty, Tara is on top of things. So she has an answer here. Close to 0, very weak to no association. Closer to 1 or -1, very strong association. So remember that 0 is no association. 1 is a very strong positive because it's sloping up, positive association, and -1 is a very strong negative association because it is sloping. It's not sloping, yeah, it's sloping down. What kind of sloping down? Next, how can you use a residual plot to assess the fit of a linear regression model? Miriam will be watching this one because she taught you guys how to do this. All right, we got a lot of good answers back here. So, yeah, I guess we're spotlighting anything. We can spotlight anything. We've got a ton to spotlight. So, Miriam told you guys this. It has to be randomly scattered, no pattern at all. And that means you have you can use a linear regression model for it. Next, how do you use a linear regression equation and a residual plot to calculate actual data values? All right, we have some good answers down here. Hang on. Iman wants to be spotlighted. Let me find it. Okay, here. For equation you plug. All right, so you can use your equation, you plug in that value, and then you can use that y hat, so actual minus predicted, and you can find like how far off your value is, if that makes sense. You got to use two parts. You can't just do one. All right. Lastly, describe how to identify an outlier and how they can affect the results of a linear regression analysis. All right, Tara is on top of things again. I will put Iman's yes. Okay, thank you, Miriam. I think that was Miriam. And then we can have that. Those are the two parts of the answer. All right, so how to identify an outlier. I taught you guys this one. So 1.5 IQR or in Q1 and Q3, or you can talk about two standard deviations. That's probably not very useful right now, but it still works. And what can an outlier do? It can bring down your correlation, and then it can affect your slope and your y-intercept as well. Oh, that was Jed highlighting. Okay. And high residual, yes. Good point, Jennifer. And make sure, Josh just told us, that you need to compare all the other points on the data set. So you want to find the largest residual in the data, which is usually the one that's furthest away. All right, back to Miriam for PEP statistical escapades.
Okay, guys, so we're going to be doing another one of PEP statistical escapades, which is just like FRQ practice, which I know you guys need and want and are dying for. Okay, so for this one, Pep has been working on his physical figure as of lately. He has found that the amount of time he spends in the gym in minutes serves as a fairly good predictor of the amount of reps he completes when at the gym. The data is modeled in the scatter plot to the right. So on the x-axis, we have the minutes spent in the gym, and on the y-axis, we have the number of reps completed. So describe the relationship shown in the scatter plot. So make sure to talk about strength, trends, unusual features, and form. Okay, so I see some good answers in the chat, which is great. Okay, so for this one, there is a positive, moderate, linear relationship between the minutes spent in the gym and the reps completed. And we also need to say as the number of minutes spent in the gym increases, the number of reps also increases. Okay. Maybe reveal the answer. Yeah. Okay. And then there's also one potential outlier, around 35 minutes spent in the gym with approximately 22 reps. Okay, so this is our favorite, the computer output for the linear regression analysis. So identify and interpret the slope of the regression line. Okay, I see a lot of good answers in the chat as well. Okay, so I think we can reveal the answer now. So for every increase in 1 minute spent at the gym, the predicted number of reps completed increases by 0.958. So if you guys remember, the first column, the bottom one is the slope. That's 0.958 in this case. So slope is 0.958, and then we say for every one x increase, the number of reps increases by the slope. Okay. Next. Okay, so now identify and interpret the y-intercept of the regression line. Okay, so I see some good answers in the chat, so I think we can reveal the answer now. So when 0 minutes are spent in the gym, the predicted number of reps is 18.33. So good job, guys. You remembered that the y-intercept is like the top of the first column, and when we talk about it, we say like when x is 0, y is this using context. So this doesn't really make a lot of sense because PEP can't do 18 reps in 0 minutes. And when we're describing y-intercept, it usually doesn't really make a lot of sense, but it's okay. We got this. Okay, next slide. Okay, the coefficient of determination is given by r squared equals 0.384. So interpret this value. No, you don't have to say it doesn't make sense on the AP exam. Okay, we got a couple answers. It would be great if we could get a few more. Okay. Okay, so the R squared is 0.384, so 38.4% of the variation in the number of reps is explained by a linear relationship with the number of minutes spent in the gym. Okay. Okay, now determine the equation for the line of best fit. Be sure to label all variables in context. Yeah, it might be hard to see all the values in order to do this. So the predicted, oh, sorry. We want to go to the other slide with the mini tab output. Okay, yeah. Yeah, so you guys can take a look at that and the mini tab output and try to figure out what the line of best fit equation would be. Okay, instead of saying y hat and x, what we want to say is use the variables in context. So instead of saying y, we would say the predicted number of reps. And instead of saying x, we would say the number of minutes spent in the gym. One thing that's not shown on the screen is like the hat. So we need to make sure to include the hat. So predicted number of reps with a hat on top equals the y-intercept value plus the slope value times the number of minutes spent in the gym. Okay, I think we're gonna move on now. Okay, find and interpret the residual for the point where 25 minutes was spent in the gym. I don't know if you guys can see it very well, but for the point with 25 minutes spent in the gym, the y value from the graph is like around 32. And if you guys saw the equation, I know it's like still in the chat, so you guys can use that to find out what the y hat is. Okay, I saw a few correct answers in there. So the residual is the actual minus the predicted. Okay, so the predicted is equal to 18.33 plus 0.958 times 25, just based on the equation that we found from the least squares regression line. And we're going to plug in 25 as the x value, and we found the predicted. And then just taking a look at the graph, the actual value is around 25, 32, or 32.5, something around that. So, or 31. So we would calculate the residual as 31, which is the actual value from the graph, minus the predicted value, which is 42.28. And then when we subtract that, we get a residual of negative 11.28. And then to interpret that, we would say that our model is an overprediction by 11.28 reps. And we know that it's an overprediction because the value is negative, which means that since the residual is an actual minus predicted, that means that the predicted is more than the actual, since the predicted is a negative. So that means that the prediction is more than our real data, which is an overprediction. Okay, so one of the points in the scatter plot is an outlier. Identify and explain why this point is an outlier. Okay, I saw some good answers in there. So the outlier is 35, comma 22.5, or the point where 35 minutes and 22 reps were completed. And you could say, as a justification for why that's an outlier, it's because it has a large residual that is way larger than any. Okay, good job, guys. That was really good. Hopefully the FRQ on the real test will be as easy or way easier than this. Okay, I think we can now move on to our Cram quiz.
All right, so this is a little preview into probability. This is also part of Unit 2, apparently. So an independent event is something that does not affect. So maybe like your shoe size and your shoe color, like they don't matter. Like there's no correlation between the two. So our most common wrong answer was C. Both events happen simultaneously. That is not independent. That basically means they're happening at the same time. So they cannot happen at the same time. That was a really bad one. Okay, sorry. So basically, independent is when they just don't correlate to each other at all. All right, this is also a little preview into tomorrow's cram. Promise I was choosing from Unit 2, but you guys did really, really good still. I think one person missed it because there's 33-ish. All right, simple random sampling is basically, all right, so simple random sampling is basically like putting everybody and then just randomly picking. So cluster sampling, stratified random sampling, systematic sampling are wrong. I hope you guys know why. We will go into it tomorrow. Alrighty. I am well aware that these are not Unit 2 anymore. Whoops. I simple random sampled the questions, obviously. Gotta make sure you guys knew what was in Unit 2 and what wasn't. Just kidding. But, alright, so, as I know somebody said, Jennifer said, is that nothing changes, or there's no. So our null is always there's no. This is Thanks, Jed. There's no association between sport types and grade level. So we're assuming there's nothing at the beginning. Guys, this is Unit 2. If you tell me this is not Unit 2, you're not paying attention. I'm proud. You guys did so good. All right, so everybody got it. Strong negative linear association. So strong because it's bigger than 0.8. So that's going to be strong. So that gets rid of A and D. And then we say positive or negative. Obviously, the number is negative, so it's going to be a negative linear association. Good job, guys. Alrighty. Which of the following would indicate a possible violation of the assumption that the relationship is linear? All right, so we taught you guys this one as well. We did okay. We didn't do too good, but close enough. All right, so B and C are just pretty much wrong because B is basically a consistent spread of residuals, is basically perfect for a linear relationship. And then D, randomly scattered points around the horizontal axis at 0. That is fine as well. Yes, Casey. Okay, so our correct answer will be A, a clear pattern, such as a curve or a systematic deviation from 0. So remember how we had the, okay, I'm not going to try and pronounce that. But if we have that, that is definitely not going to be linear. So we talked about how we cannot use a linear relationship to describe that one. Alrighty. Okay. What is extrapolation? Making predictions outside the range of values of the explanatory variable present in the data set. Okay, so B is going to be interpolation, which I talked about, which is when you have like data points and you're trying to make a prediction between them. So that was 2 people. That's okay. That's not bad. And then we have D, minimizing the sum of square differences between observed and predicted values. That is not related to extrapolation, unfortunately. So yeah, A, 90%. That's pretty good. That's like 30 of you guys. Good job. That's okay. All right, that's okay. Alrighty, so we tied with to calculate the correlation coefficient between variables. B is to assess the goodness of fit. All right. Chet is gonna have a little, okay. All right, so we have a little bit for each answer. So A, to estimate the standard deviation of the response variable. No, that one is gonna be your, there's a formula that Miriam, I believe, dropped on preview night 1 that we can use for that. B, to assess the goodness of fit of the regression model. So remember, we're trying to figure out if we can use this to do a linear model or not. So can someone get that question in the chat? Okay. To assess the goodness of fit in the regression model. So we're trying to figure out if we can sorry, there's so much going on in the chat. We can use it to do a linear. So we want to know if that works. So we want to do the sum of squared residuals to find out if we can do it as linear or non-linear, or not linear. So we say you can't do it. C, to determine the range of the independent variable. Unfortunately, no. So residuals are the actual minus expected. So that's not going to be that's going to be only for one value of y, not the whole range of the independent variables. And lastly, calculate the correlation coefficient between variables. That is a formula I do not know, but you can do that on your calculator. So that is not how you calculate the correlation coefficient. And that is the end of our Cram quiz. It is time for a little Q&A.
Oh, before we end the Q&A, I just wanted to add on, for that last question, the correlation coefficient is R, but the sum of the squared residuals is S. So when we're talking about the residuals show how far away our points are away from our line. So the sum of squared residuals is if you have a bigger sum of squared residuals, that would mean that you have a worse estimate of your graph. And then if you have a smaller one, that would mean that your estimate is closer to the actual data. So then what that means is that it would assess the goodness of fit of the regression model, because the sum of the squared residuals is what we're trying to minimize when we're creating a least squares regression. And as opposed to that, R only goes from -1 to 1. So that's
Thanks for helping out, Miriam. We are on to our Q&A, I believe. I didn't know. Okay. Alrighty. Q&A. So we have a little crowd here to answer your questions. We'd rather prefer if you guys drop them in the Q&A so we can see them. The chat goes by really fast. So we can just go off, read questions. I can read one first and then someone can answer it. Somebody want to know, can we explain variance again?
So yes, I saw the question about variance, and basically all variance is the standard deviation squared. All right, so I'm going to share the formula sheet. We took a bunch of excerpts from the formula sheet, but I'm going to share the formula sheet and let us kind of look at that for a minute. So the standard deviation formula is this booger right up here in the top right. More than likely, you're not going to use that formula. If you need to calculate the standard deviation, you will more than likely put that in to the calculator. However, almost certainly, you're not even going to need to do that. What more than likely is going to happen if you are asked to calculate standard deviation, it is going to be standard deviation of a random variable, which is binomial, maybe discrete, although that's a pretty nasty formula, but binomial and geometric. And it's really important that you understand what the interpretation is for standard deviation, more so than the formula, especially with this, yes, I did say booger, this booger of a formula, because that would take a long time. I don't think they're going to give you that question. More than likely, if they ask you to calculate standard deviation, be very mindful that it very well is probably one of these standard deviations of a probability distribution, or if you go to the next page, which we'll get to later in the weekend, the standard deviation of a sampling distribution. Those are a lot more calculatable. There's some more Alabama vocab for you, calculatable. All the variance is the standard deviation squared. It's really not that useful other than in terms of telling us that it is the how far spread out the data is. But typically we would use standard deviation. So if you kind of were making notes about what standard deviation means, you may want to add that standard deviation is the average distance from the mean. That's what you're looking for. So let's say it asks you to calculate and interpret the standard deviation from blah, blah, blah. Use the appropriate formula. It's probably not this guy up here. It's probably one of these a little bit more succinct formulas. And then you would say the average distance from the mean of blank is whatever the standard deviation is. So great point there. Make sure you focus on that interpretation of standard deviation. And it's basically the same no matter what formula you're using, if it's a sampling distribution or a random variable, or just a set of data. The standard deviation of this univariate set of data is 6. What does that mean? They could very well ask that. It is the formula sheet that you will get on the AP exam. All right.
I can find some more questions. I figured out how to scroll on my computer now so I can see the Q&A. Alrighty. What measure of variability and central tendency should you use for bimodal? I think we should save that for Jed on night 3, or we can answer it now. I don't mind.
Can you repeat the question?
Yeah,
that you just
I know
said?
I froze because I saw both
Okay.
of you guys freeze, and I was like, oh no. Okay, there's a
there you
question about bimodal distributions. Do you want me to save that for Jed and like that group when they're teaching it?
Excuse me, I see that there. So no, not really. So bimodal distributions is more so in Unit 1. For variability and central tendency, I would basically say for that, just use median and IQR. Median and IQR are almost always a safe bet, whereas mean and standard deviation are not good when it is symmetric. So if it's bimodal, it very well could be symmetric, So mean and standard deviation could be okay, but the safe bet is to always use median and IQR, or for variability, say that the data varies from 0 to 12, whatever. Let's see, I'm gonna try to pull up a bimodal distribution from our slides. And so we can kind of see that there. All right, let's see. So bimodal is the one down here in the bottom right. So it is symmetric. That is true. It is symmetric. It's just not symmetric and mound shaped. It has two mounds. It's like a camel. So mean and median are going to be close to the same. But I think the safer bet is just to use median. And Jed agrees. He said he would use IQR for bimodals. Median, IQR, mean, you're kind of running a risk of getting something wrong, whereas median is never going to be wrong unless if the question is, when should you use mean and median? Then it's kind of, that would be where you would want to mention the mean.
All right, we'll continue on with we don't have that many questions today. So someone wanted to know, what is the spread? And then the question after that is, what's the point of the variance? You're muted. You're muted.
What was the question again?
Oh, sorry.
I think my computer's lagging a bit. Sorry.
Oh, you're good. What is the spread? And then after that is, what is the point of variance?
So spread, when you're doing SOCS, is just what the data varies from. So like if the minimum is 0, the maximum is 12, you could say the data varies from 0 to 12. You could say the range is 12 because 12 minus 0. You could also, in spread, mention the IQR. The IQR is a measure of spread. So spread and variability basically are the same thing. Some teachers do SOCS, some teachers do SOC-V. I personally do CUS, center, unusual features, shape, and spread when you are determining, describing the distribution. All of those work, but the spread is just how much it's spread out. I will mention this, and this is like, we're in crunch time. We got 5 days left. The 2 steps, PEPS statistical escapades that we did tonight that our student host went over, I hope that you printed out the Google Doc that we shared in the call to action down below, and you were working it out with us, and then you were checking your answers. But if you print out the slides, you will get the answer key. On your free response section on your exam, number 1 is going to more than likely look very similar to one of those 2 questions. So we're thinking game planning for the exam. That is what you can expect to see on number 1. And we'll rehash these questions again on let's see, Monday night in our last stream. So number 1 on FRQ is going to be on describing data, which would be one of the 2 free responses that we saw tonight. If you look at last year's exam, then you can see that like number 1 was very similar to the weather question. And actually number 5, which is one of the kind of mixed bag questions, was very similar to the second one where PEP was lifting weights. So knowing those 2 escapades would have really prepared you for number 1 and number 5 on last year's exam, which is super, super important. I'm really excited about that. The call to action just popped back up down below. You can click and print that. I put together the 2 questions for tonight in one document that you can kind of have to hold and to cherish. Tomorrow night I think we do 3 tomorrow night, which will be fantastic. And again, they're based off of what you can expect to see on certain questions on the AP exam. So the answers are posted in the slideshow. So if you print out the slides, the answers for those questions are on the slides. So that would be the best way to do it. I want you to print them out and work them out as we go. But then, if you want to go back and look at the answers, those are the answers we're going over during the stream. All right. Make sure y'all are taking that survey. We'll put that back up. It looks like we're getting ready to call it a night. Any other questions? Here's a good one. Will we be asked to make any graphs like mosaic or bar graphs, or just identify them? It is very possible that you would have to create a graph, probably not a mosaic plot because those are kind of weird to do, but they very well could. A few years ago, they asked you to make a segmented bar chart, which a mosaic plot is just a slightly more intricate segmented bar chart. So that's very possible. It is a bit more niche-y. I like that term. It's kind of a new thing in the stats world. And, yeah, let's see. I think I can actually pull up a document real quick that I can share with you on graphs. Just give me just a second and I'll post it in the chat. All right. It is a graphs you need to know. A graphs you need to know document that you can study for graphs you need to know. All right, let's see. Let me pull up the right tab again. Okay, so this is going to be in the chat. So that document there is several graphs that you can just look at and be like, oh yeah, stem and leaf plot. I need to remember. Oh, we've Ivan again. It's probably me because I was changing tabs. It was. Oops, sorry. But yeah, so that document there that's in the chat is let's see, I'm also going to make it a call to action if I can. That way for the replay, you can get that pretty quickly. Graphs to know. Create. My call to actions are not working for some odd reason. If one of the student hosts can make that a call to action and put that up real quick.
If you'd like, I can do it. Yeah.
Yes, if you would. That way it'll be accessible for the replay. That would be great. Okay, let's see. Yes, so last year the question was to draw a box plot. 3 years ago, it was to draw a box plot. 2 years ago, it was segmented bar chart. I think somewhere in the free response, you will have a question asked to draw some type of graph. And that document has, I think, all of them that you would see. So that graphs to know call to action down below is something that I've made for my students. So there you go. Oh yeah, those Unit 4 free they're a booger. That's going to be our word of the week. And we have a few of those tomorrow night that we're going to do. So for sure. I expect more questions tomorrow night with the probability section. All right. Any other questions before we hop off of here and call it an evening? All right. Y'all have a fantastic night. Great job, everybody. You are going to do fantastic on your AP exam. Keep grinding for the last few days, and we will see you all tomorrow night. Good night.